Good morning all. I Salim, Assistant Professor in Kite Group of Institutions, presenting you phase locked loop, importance of phase locked loop or PLL in telemetry system. A phase locked loop, it also called phase locked loop or phase lock loop, is a control system that generates an output signal whose phase is related to the phase of an input signal. There are several different types. The simplest is an electronic circuit consisting of a variable frequency oscillator and a phase detector and a feedback loop. The oscillator generates a periodic signal and the phase detector compares the phase of that signal with the phase of the input periodic signal. Means phase detector compares the phase of input and the output or feedback signal. Okay, and adjusting the oscillator to keep the phases matched. Here is the diagram, block diagram. Here we have input signal or reference signal. Here is our PLL, phase locked loop. Here is the output signal. In this, our output frequency should be equal to the input frequency. There is no phase difference, means del phi is equal to 0 or constant. Here are the examples. In this image, we have a constant phase difference between two signals, and in this case we have variable phase difference. So here we can say in this the phase lock loop is working. Phase lock loop contains phase detector, low pass filter, variable oscillator, voltage controlled oscillator, not variable oscillator, voltage controlled oscillator. Here is our reference signal, here is our output signal. So it is the example of how phase detector works. Here is the frequency of reference signal, here is the frequency of feedback signal. It comes from here. So it gives me f1 plus f2 or f1 minus f2. Low pass filter generates low frequencies only. It gives me low frequencies. It gives me f1 minus f2. So here is the working of phase locked loop. Phase detector. First component is phase detector. The phase detector detects the phase difference between the variable controlled voltage controlled oscillator and the input or the reference signal. Based on the phase difference, it generates the error signal. At radio frequencies, RF frequencies, the balanced mixer is used as a phase detector, while for digital signals the XOR gate and phase frequency detector is used for the phase detection. Low pass filter. Low pass filter removes the high frequencies components from the error signal and generates the error voltage. The error voltage is fed to voltage controlled oscillator for the frequency correction. Next component is voltage controlled oscillator. Based on controlled voltage, the output frequency of voltage controlled oscillator can be controlled around the center frequency. Full stop. Based on error voltage, the output frequency of the voltage controlled oscillator changes until the voltage controlled oscillator frequency is equal to the input frequency. Means our VCO works until when our reference signal frequency and our output frequency both are same. Phase detector generates error till when these f1 and f2 both matches. Then lock condition, when the VCO frequency is the same as the input frequency and there is no phase difference or constant phase difference between the two signals, then loop is said to be in lock condition. like in our example 1. In this case we can say that our phase is locked. Then application of PLL, frequency synthesizers, tone generation, system clock generation, and for clock distribution in processors, for noise reductions, for clock recovery, we can use phase lock loop. Here is the example of phase detector. XOR gate is used as a phase detector. Let V1 voltage is this, P2 voltage is this. There is no phase difference between V1 and V2, so we can say zero phase shift. When voltage here is our V1, here is V2, there is a 90-degree phase shift, and in this case phase difference is 180 degree. This is all about phase lock loop. Thank you.